All right, today we are going to play detective, but this isn't your typical mystery. Our suspects, they're penguins. Our crime scene, it's a data set. And, our lead investigator is going to be a machine learning model. We're going to figure out who these mystery penguins really are.
So here's the central puzzle, the big question we're trying to answer. Can a computer really identify a penguin species, or even its sex, just by looking at some numbers? Things like its flipper length and body mass? We're going to see if we can teach a machine to do exactly that.
So this is our case file. We've got all this data on a whole colony of penguins, but there's a catch. For a few of them, some really important info is just gone. They're basically the John and Jane Does of the penguin world. And it's our job to give them back their identities.
To crack a case like this, you need a solid plan. We're going to follow a classic 4-step process. First, we got to clean up the clues. Second, we choose the right detective for the job. Third, we train up our champion. And finally, the best part, we solve the case. So let's get our investigation started.
Okay, step one. Every good investigation starts with securing the scene and organizing the evidence. And in the world of data science, that means cleaning up our data. We absolutely cannot have our detective tripping over messy or incomplete information. It just won't work.
So the first thing we do is find our mystery penguins and we set them aside. They're like the final exam. And it is so important that the model doesn't get to peek at the answers, right? This prevents something called data leakage and makes sure our test is totally unbiased. Then we go through the rest of the data and just get rid of any other incomplete records. What we're left with is a super clean, pristine set of clues, which is perfect for training our detective.
All right, our evidence is clean and organized. Now we need to pick our lead investigator. And here's the thing. Not all machine learning models are the same. Some are just better at certain tasks than others. So what do? We hold auditions. We're going to see which detective performs the best. So after testing a bunch of different models, a clear winner stepped forward, the random forest classifier. Now look, it didn't just have the highest accuracy, meaning it got the answer right more often. It also had the lowest standard deviation. And that is so important. It tells us its great performance wasn't just a fluke. It's consistent, it's reliable, and that's exactly what you want in a detective. So what in the world is a random forest classifier? Well, it sounds complicated, but the idea is actually pretty cool. Imagine you have a really tough problem. So you bring in a huge team of experts. Each expert looks at the evidence from a slightly different angle and gives you their opinion. Then you just make your final call based on the majority vote. That's basically what this model does. It builds hundreds of these little mini decision trees and then combines all their insights for one super powerful, super reliable prediction. And just for a quick peek behind the curtain at the tools of the trade, the huge majority of this detective work, over 92%, was done in what's called a Jupyter Notebook. It's kind of like a digital lab for data scientists, and it's all powered by the Python programming language. Okay, so we've picked our detective, the random forest classifier. Now it's time for boot camp. We need to let our model really study that clean data we prepared so it can learn what a Gen 2 or an Adelie or a chinstrap penguin looks like, statistically speaking. During this training phase, the model is just meticulously going through every single complete record we have. It's learning all the subtle connections between, say, flipper length and beak depth, and how those patterns point to a specific species and sex. It's kind of like it's building its own internal field guide to penguins, but using nothing but numbers. But hey, before we send our detective out on the real case, we have to run one last check. We use a technique called cross-validation, which is a lot like giving the model a series of pop quizzes on the data it just studied. This just confirms that it learned its lessons correctly and that it's actually ready for the final challenge.
All right, this is it, the moment of truth. Our data is clean. Our detective is trained, it's ready to go. It is time to bring in our mystery penguins and see if all this hard work is going to pay off.
Remember those unidentified penguins we set aside at the very beginning? Well, they're back. We're now presenting them to our trained model. Now, the model has never, ever seen these specific penguins before, but it has been trained to recognize the patterns they represent. So the model takes the measurements of each unknown penguin, and based on all that intensive training, it makes its final prediction. It calculates the most likely species and the most likely sex for every single one. And it works. Success. The model fills in all the blanks, assigning a species and a sex to every penguin that was previously a mystery. Our data detective has officially cracked the case, turning a whole bunch of question marks into solid, concrete answers. So, what's the big takeaway here? What's the moral of our penguin story? Well, it's that with a clear, methodical process,
cleaning your clues, choosing the right tool for the job, and training it properly. Machine learning can find answers that are hidden right there in the data, just waiting to be discovered.
Now, this whole thing might seem like it's just about penguins, but this principle, this process, it's universal. And it leaves us with one last question to chew on. If a simple, structured approach like this can identify a penguin from just a few measurements, what other, maybe more complex mysteries in our everyday lives are just waiting for the right data detective to come along and solve them?